So question 2, sketch this graph. First of all, as always, preliminary step, factor. The top cannot be factored, but the bottom, x plus 5, x minus 5. Step 2, state your non-permissible values. X can't equal negative 5 and x can't equal 5. And now we have to decide, are these going to be vertical asymptotes or holes? Well, they don't simplify away, so both of them are vertical asymptotes. Perfect. Step 3. Decide if we have horizontal asymptotes or oblique asymptotes. Now, nothing simplified, so we're still using the original equation. In example 1, something simplified, then you look at your simplified equation from now on. And last time that simplified equation was a line, which you already know how to graph, so you didn't have to do steps 3 and 4. This one, nothing simplified, so we look and we recognize that the degree is the same in the numerator as the denominator. Whenever the degrees are the same, you will always have a horizontal asymptote, and that horizontal asymptote will be at the coefficients of that highest degree. So you just look at the negative 2x squared over the 1x squared. Negative 2 over 1 simplifies to negative 2. That's your horizontal asymptote. So now we can start graphing. Put on all of our asymptotes and label them. And step 4 was doing our nice points. So we always find out our x-intercepts and y-intercepts. Yes? Oh, sorry, thank you. Oh, look at that. Horizontal one's going to be at negative 2. Thank you. So our nice points for our y-intercepts, well, that's easy. You plug in 0 for x. Can you see that you are going to get 0 over negative 25? 0 over negative 25 is just 0. So you have the point 0, comma 0. For your x-intercept, the only place a fraction is equal to 0 is if your numerator is equal to 0. So I have negative 2x squared. Hopefully you can see that that too only happens at 0. So in this case, our x-intercept and y-intercept are the same. Now we have to find some other points in order to graph it. Okay? Now, a little bit tricky in this middle section because it's in the middle. You know that your graph can go through a horizontal asymptote. It sometimes does in the middle of your graph. So in this case, we're wondering if that is what happens or whether or not it goes up forever or down forever. Okay? Looking at this, what I could do then is I could plug in some points. So if I want to see, does it go down forever, up forever, I need to plug in a point between 0 and 5. And it doesn't matter which one you do, 1, 2, 3, or 4. If I choose, for example, 4, my top is going to be negative 2 times 16 over 9 times negative 1. That simplifies to be 32 over 9. 32 over 9 is somewhere between 3 and 4. So if I plug that point in, First of all, 1, 2, 3, 4. 4 comma 32 over 9. You can kind of just estimate where that would be. Well, that tells me this section is going up towards my asymptote. If you plug in -4, well, -4 squared is still 16. -4 plus 5 is 1. -4 minus 5 is -9. You get 32 over 9 again. And so it goes up towards the asymptotes in both situations. Do we have enough nice points yet? No. We've only graphed the middle section between x equals -5 and x equals 5. So we're going to have to plug in -6 and possibly +6 as well. You could have plugged in 7 if you'd like, or 8 or 9, anything bigger than x equals 5 or less than x equals -5. So if I plug in -6. -6 squared is 36. -6 plus 5 would be -1. -6 minus 5 would be -11. If I multiply this all out, I'm going to get -72 over 11. Can you see that with the 3 negatives that we know my fraction is going to be negative? 2 times 36 is 72. 1 times 11 is 11. Estimate where that would be. -6, -72 over 11. And since it's here, this part of our graph has to go towards the asymptotes in those situations. If we look at plugging in +6, +6 plus 5 will be 11 here. And 6 minus 5 is 1. We still have a negative. It still multiplies out to be the same point, 6 comma 72 over 11. And so it's symmetrical on that side as well. The symmetry in this one, if you look at the original equation and ask yourself, does it make sense that it's symmetrical? Does it make sense that if I plug in 5 or -5, when looking at the original equation, it shouldn't make a difference? I should get the same answer every single time. Because when you square a negative, it becomes positive anyways. So that symmetry makes sense in this equation. Some things else that you look at, notice how it's sort of like we have a bounce at x equals 0. Can you see that x equals 0 sort of has a multiplicity of 2 connecting to another unit that we've done? So sometimes if we can make some of these connections, we can understand things a little bit further. Okay, for the domain, it says state the domain. X can't equal 5. X can't equal -5. But x can be everything else. So try graphing number 4.